Hey boys and girls, this is Mr. Giomini coming to you with another problem that you will see on the math test come Friday or Monday of next week. And this is a problem that I would have to say that probably about 90% of you guys missed. And it's a tough problem, so let's take a look at it a little bit more closely in detail. So if I read here, use my point and say here, Mrs. Jenkins is packaging science supplies for groups of students. She has 40 hand lenses, 32 pairs of tweezers, and 28 pens. She wants to package the supplies so that every group has the same number of hand lenses, tweezers, and pens. Use prime factorization to determine the greatest number of packages she can make without having leftover items. Then determine the number of hand lenses, tweezers, and pens that will be in each package. Holy cow. So if I take a look at this, I definitely know that I have to first use prime factorization. This is number one for this. To determine the greatest number of packages. The greatest number of packages that she can have or she can make without any leftover items. And then it says, then determine, so this is part two, the number of lenses, tweezers, and pens that will be in each package. So now I have to figure out the number of packages, but then how many hand lenses, tweezers, and pens will be in each package. So if I have 40 hand lenses, 32 pairs of tweezers, and 28 pens. Alright, keyword here is use prime factorization. Many of you guys are used to the word factor tree. So I do a little labeling here. So I have my H, which is my hand lenses. I have my T, which is for my tweezers, and I have my P, which is for my pens. So if I take a look, we have 40 total hand lenses that I have to split up amongst all the packages. 32 tweezers and 28 pens. Now I have to take those and split them amongst packages. So let's use prime factorization. I'll go 8 times 5. 5's prime, so I'll stop there. Remember, it's prime factorization. I want to find all numbers that are prime. 4 times 2. 2's prime, so I'll stop there. And now I'll go 2 times 2. Now I'm just going to write this as this. 2 times 2 times 2 times 5 equals 40. 2 times 2 is 4. 4 times 2 is 8. Times 5 is 40. Alright, good. Let's go to 32 now. What times what equals 32? 4 times 8. Neither of those numbers are prime, so I'll keep breaking it down. 2 times 2 is 4. Those are both prime, so I'll circle both of them. 4 times 2, 2 is prime, I'll circle it. 2 times 2, they're both prime. So if I look at this, my circle numbers 1, 2, 3, 4, 5. I have 5 2's, so let's go 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Now go to my pens. 7 times 4. Well, 7 is prime, I'll stop there. 2 times 2. That's prime. So my prime factorization for 28 is 2 times 2 times 7. Now I can also write this using an exponent. It's 2 to the third times 5. I can also write this 2 to the fifth because I have 1, 2, 3, 4, 5 2's. And I can write this as 2 to the second times 7. So I've broken it down to prime factor. Now I got to find the greatest number of packages. Well, what I have to do now is I have to look for what factors do they all have in common. Well, this has a 5, but none of the rest have a 5, so I'm going to cross a 5 out. It can't be 5. This has a 7, none of the rest have a 7, so I'm going to cross that out. Now, they all have 2's, but the problem is what's the greatest number? So, we have a 2 here. We have 1, 2 here. We have 1, 2 here. Okay, good. We have a 2 here. We have a 2 here. We have a 2 here. Okay, good. I don't have any more numbers here, so that means that I can't use this 2, this 2, this 2 because that doesn't have it all 3 in common. And I can't use this 2 because we don't have it all in common. So the only thing they really have is the 2 2's. And we know that 2 squared, or 2 times 2 equals 4. So that tells me I can make 4 total packages. Because 4 is the greatest number that I can break these into different packages so that nothing's left over. Now the trick is here, now I have to determine, that's my second part, so this is only my first part. My second part now is determine the number of lenses, tweezers, and pens that will be in each package. Well, if I have 4 total packages, I am now going to take hand lenses. 40 divided by the number of packages I have, which is 4, that'll give me 10. So I'll have 10 hand lenses, HLs, in each package. I'll then take 32, and I'm going to divide that into 4 different groups. 32 divided by 4 is 8 pairs of tweezers in each group. Now I take pens. I have 28 pens. I divide 28 by 4. I'll have 7 pens in each group. And there's my second part of the question. So going back, let's see if I answer my question. Use prime factorization. Check, I did that. To determine the greatest number of packages, I have the greatest number of packages. It is 4. That she can make without having leftover items. Well, I have nothing left over here, so I'm good. Then determine the number of lenses, tweezers, and pens that will be in each package. Well, 40, because I have 40 total hand lenses, divided by 4 groups. That gives me 10 hand lenses per group. 32 tweezers. 32 divided by 4 equals 8 tweezers. And finally, 28 divided by 4 equals 7 pens. Now, it doesn't say I have to have the same number of these in each group. It just says I have to have the same number of packages. So, there's my final answer. Hope this helps you out a little bit for the test on Friday. Have a great day, boys and girls.